Great. So we can start. Hi, everyone. I am Elisa Carignani, researcher at the Italian National Research Council, and I'm an Italian IUPAC Young Observer. I'm very pleased to welcome you all to this Chem Voices webinar. IUPAC at the forefront between chemistry and environment. As you may all know, Chem Voices is the result of a partnership between IUPAC and IYCM, and it was created to showcase the talented impact of early career scientists worldwide. Well, we are celebrating the Earth Month and Earth Day 2023 just passed, so we think there's no better occasion to showcase and talk about the IUPAC commitment for the environment. We will do so thanks to our speakers. We have a great and diverse lineup of speakers from 3 different continents. So welcome to our speaker. We will have Professor Roberto Terzano, President of IUPAC Division VI from University of Bari. We will have Dr. Silvina Di Pietro from Lauerson Livermore National Laboratory in USA, California. And we will have Dr. Jyoti Giri from Tribhuvan University in Nepal. So let me first thank the speakers and all of you for attending. I hope you will enjoy the program and find inspiration from the different experiences that we will hear about. So for all of you, please engage and join the conversation by posting a question in the question and answer box. You can post question anytime, and we will have sometimes after each presentation and at the end of all the 3 presentations. So let's start. Let's start with our first speaker. Our first speaker is Professor Roberto Terzano, professor at the Department of Soil, Plant and Food Sciences at University of Bari. His scientific activities concern research topics in various fields of agricultural, biochemistry, and soil chemistry, with a particular interest in the use of X-ray to study environmental matrices, cultural heritage, and biogeochemistry of trace elements in soil plant system. So today, Roberto is here as president of IUPAC Division VI, and he will give us an overview on IUPAC Division VI activities. So thank you, Roberto, and please.
Thank you, Elisa, for your kind presentation. Can you see my screen?
Yes, we can.
Yeah, and can you hear me correctly?
Perfect.
Okay, so thank you very much for giving me the opportunity to introduce the activities of our IUPAC division, chemistry and environment. So in the first part of my talk, I will briefly speak about IUPAC for those of you who are not much familiar with this organization. So IUPAC is the International Union of Pure and Applied Chemistry, and IUPAC is an indispensable worldwide resource for chemistry, whose mission is to provide objective scientific expertise and develops the essential tools for the application and communication of chemical knowledge for the benefit of humankind world. In IUPAC, we believe in different important values like scientific excellence, communication, transparency, diversity, and ethical behavior. IUPAC is very well known among chemists all around the world for its role in setting and recommending standards, in particular in nomenclature, terminology, and symbols. But IUPAC is much more than this, and today we would like to give an idea of additional activities of IUPAC. IUPAC also shares emerging science, organize safety training and education programs all around the world, published journals, books, and databases, endorses symposia and conferences all around the world, and also awards prizes to honor scientific contribution and expertise. But overall, we are a group of volunteer chemists from all over the world, and this is very important from my side. Everything is done within IUPAC is done only on a voluntary basis. At present, 55 nations are affiliated with IUPAC, as you can see from this map here, where you can see the distribution all over the world. And IUPAC is organized in divisions that reflect the different branches of chemistry. You can see there is a division of physical and biophysical chemistry, and inorganic chemistry, organic and biomolecular chemistry, polymer chemistry, analytical chemistry, and today I am representing the Division VI, the so-called Division VI chemistry and the environment. The aim of our division is to provide unbiased and timely authoritative reviews on the behavior of chemical compounds in food and environment, and to contribute solving environmental problems and enhance the quality of food on a global scale. These are our main objectives. At present, the division is made of 26 members from 20 countries, 5 continents, and of which 14 are males and 12 females. This just to show you that we really believe in also in balance in between males and females, and also in diversity is very important in IUPAC in general. The activities of the divisions are mainly carried out by 2 subcommittees: the Advisory Committee on Crop Protection Chemistry and the Subcommittee on Chemical and Biophysical Processes in the Environment. And in addition, from starting previous year, we also established a division group of young observers, because we believe that the contribution of, I don't want to say young, but younger scientists, because most of them are already well experienced scientists, is very important for our division and for IUPAC in general, to give new blood, new energy for the development of the union. You will listen, of course, to 2 of them in the next 2 presentations, and I'm very pleased that International Younger Chemistry Network has organized this event, also to show what younger scientists can do within our division. As IUPAC division, what do? We do many different types of things. I'm just showing here a few of them. We write and publish books and scientific papers on relevant environmental chemistry topics. We organize conferences and workshops all around the world. Just an example, this is the banner of the last conference we have organized in India in March about crop protection chemistry. And we also produce informative material which is freely accessible through the IUPAC website. This is an example of the crop chem news that is prepared 2 times in a year by Advisory Committee on Crop Protection Chemistry. So after this introduction about IUPAC and Division VI, now I would like a bit to focus on the main topic of this talk, and also that gives also the title to the webinar. So as stated in the title of this webinar, IUPAC is at the forefront between chemistry and environment. In fact, as you know, over the years, chemistry has produced a lot of compounds and materials which are very important for our everyday life and have made our life better and simpler. but at the same time, some of them turn to be dangerous, both for the environment and human health. So as chemists, we have also the role and the responsibility to study the effects of these chemicals, these substances on the environment. And when needed, we have to find the solutions to reduce the impact of chemicals and chemical processes on the environment. So in the next slides, I will show you some examples of how our division is carrying on this activity of studying and finding solutions for some urgent environmental issues. As a division, you should know that we carry out our activities through projects. And so now I am just making a very short and brief overview of some of the projects in which we are actually studying the effects of certain chemicals on the environment and human health. One of these projects is, like you can see from my slide, is about the per and polyfluoroalkyl substances, the so-called PFAS, in the environment. As you know, these chemicals are present and used in many types of products, everyday life products, like fast food packaging, anti-sticking materials, and photography, firefighting foams, and so on. So they have a large amount of applications. So these molecules are characterized by a covalent carbon-fluorine bond, as you can see here, which gives them very useful properties from one side, but also make them very resistant to degradation in the environment. That's why they are called forever chemicals, so they are persistent organic pollutants. Nowadays, a lot of attention has been posed on these chemicals and their impact on the environment and human health. And through this project, we are reviewing and studying these impacts. Another project about another very important emerging environmental issue is the problem of e-wastes, namely the waste deriving from electronic devices. As a division, we have dedicated a lot of efforts on this topic, and as you can see from the first page of Chemistry International, which is one of the main journals published by IUPAC, and also a recent paper on which we reported about the global occurrence, chemical properties, and ecological impacts of e-wastes. Another problem, which is very well known and of global concern, is that of microplastics. And we know that the production, as you can see from this graph, the production of plastics is going to increase over the years, the next years. And in the same way, also the amount of plastic waste is going to increase in the next years. And so solutions have to be found as soon as possible to deal with these wastes, because as you can see from this bar here, okay, more than half of these wastes are just discarded in the environment, and so they transform into the so-called microplastics and nanoplastics, which are now creating a lot of problems to different environmental compartments. So as division, we are studying this problem with this project on the environment, health, and food safety impact of microplastics. Another example is about this topic. As you know, in agriculture, nanopesticides and nanofertilizers have been introduced in the last years because they have shown to have very positive aspects compared to their conventional analogs, like more efficient application, reduced losses, improved biointeractions. But what is the impact of these new nanomaterials used in agriculture on the environment? So as a division, we have also faced this problem and published this very important publication recently. Another recently started project is focusing on the impact of tires and road wear particles on the environment. Again, tires is something we all use every day, and they can the material of which they are produced, they can create problems to the environment. So we are reviewing how these materials released by tires can be distributed in the environment, and also to find a way to minimize the environmental impact of these materials. As another example that we are dealing with, topic we are dealing with our projects is carbon sequestration. As you know, the concentration of carbon dioxide in the atmosphere is increasing and will continue to increase in the coming years. And a way to reduce the amount of carbon dioxide in the atmosphere, besides, of course, reducing the emissions, is to capture this molecule by carbon removal, and so carbon sequestration, both on land and also in marine environment. So this is another very timely topic that we are dealing with in our division. So in general, I can say that as division, when we develop projects on environmental issues, we take into high consideration the so-called One Health approach. So we consider the health of the environment together with that of humans and all living organisms on the planet. And we try to work in synergy with the guidelines provided by other international organizations, like, for example, the International Panel on Climate Change and the United Nations. And I'm just showing here some particular sustainable development goals, which as a division on chemistry and environment, we are dealing with when we develop our projects. As I have shown to you, our activity is mainly carried out through projects. And in principle, everybody can be involved in IUPAC projects. So I invite all of you that are listening to maybe to get involved with IUPAC and with our division in particular. So in fact, anyone, as reported here, from any country can propose an IUPAC project. And for this reason, we every year we publish this call for proposals to submit projects to our division. Here there is a link where you can find instructions on how to prepare a project for IUPAC. So please take this into consideration. At last, I'm coming to the end. For those who are interested to know more about our division activities, we have a website whose link is reported here, or you can also have a look through our social media in Twitter, in LinkedIn, or just you can write to me or the division secretary, so Fanny Sacreradio, at this address. And that's all. So thank you very much for your attention, and open for questions.
Thank you very much, Roberto, for this interesting overview of the IUPAC Division VI activities. And we are a little bit behind schedule because we missed some minutes for technical problems at the very beginning. So we will keep the question for the last part of the webinar, if it's okay. So let's move on with the program. And we move from Italy to US with our next speaker, Silvina Di Pietro. Silvina is currently a research scientist at the Lowers Livermore National Laboratory, where she investigates uranium synthesis as a viable and disruptive technology for nuclear application. Sylvie got her PhD in environmental chemistry in Florida International University, and her professional interests include water chemistry, geochemistry, and remediation of contaminant areas. Sylvie is also an IUPAC Young Observer, and today she will share her experience talking about her path to IUPAC involvement, from a student to scientist. So thank you very much, Sylvie, for being here, and please.
Thank you. Thank you so much, Elisa, for your presentation. Are you able to see my screen?
Yes.
That's great. Great. Well, welcome to my presentation, and thank you all for attending this really interesting and new presentation webinar called Chem Voices. The title of my topic today will be Path to IUPAC Involvement from Student to Scientist. And I will start by giving you a really brief overview of today's presentation, who I am, how did I get involved with IUPAC, some of the IUPAC activities, lesson learned, and obviously questions. This is me at the Florida International University Soil and Groundwater Remediation Lab, and this is where I spent most of my PhD career in this lab. So it's very fond to my heart, and that's why I put this picture here. But I should start with the very early stages of my graduate career, which started in 2015 when I decided to pursue a PhD degree, which it was in combination with a master's degree. So the program was a combination. I started to take classes in 2015 at Florida International University, that is in Miami. And when I was proposed what kind of work I'll be doing, they were needing somebody who would be a representative of the Department of Energy. That's a government institution here in the United States, which were trying to remediate problems that have legacy waste from World War II and the Cold War. And so in 2015, they were needing somebody who could research the interaction between uranium and minerals from the legacy waste that happened in those two particular important events of the United States. So I started to take classes, and then in 2018, I received my master's, and then continued research and candidacy exams, as we call it here in the United States. I was able to obtain my PhD in 2021. Interestingly enough, a couple of months before obtaining my PhD, I found out about IUPAC, which I'll get to describe more later. In 2022, last year, I became a postdoctoral fellow, and so that was my transition between going from the state of Florida to California. For those of you that do not know, a little bit of United States geography, I went from the East Coast to the West Coast. There's a 3-hour difference in time zone. And in 2023, I started my research scientist position. So thank you for allowing me to present myself. These are fun pictures of when I graduated. And this is my PhD baby, my thesis. I always like to put that picture there. But what I want to talk to you about today is my pathway and my introduction to IUPAC. And so I always say that IUPAC came to me. All I knew about IUPAC was what I learned in my organic chemistry class, which was about nomenclature and structure in organic chemicals. But because I'm very involved with American Chemical Society, I always get their newsletter. And so in December of 2020, excuse me, here I have a box showing the date, December 15th, 2020, I received a really interesting email that went to my spam saying apply for the IUPAC Observer Program, Young Observer Program. And that caught my attention. And so I started to do a little bit of research. I went to the IUPAC website and I started to research what the program was about. And I said, well, this sounds like something I could do. And that's a great way for me to stay involved post-graduation. And so I really encourage you to look at your spam. What is the lesson learned? Look at your spam, because I simply applied thinking, well, maybe I could get accepted, maybe not. But then I did get accepted, and my university was very proud of me. And so they wrote an article about my acceptance to the IUPAC Young Observer Program / International Younger Chemist Network. And so for those of you that don't know this network, it's a way to get involved with IUPAC early on. But that's what my next slide is about. And so my introduction to IUPAC was indeed with the International Younger Chemist Network. This is a network for young scientists. You could be an undergraduate, graduate student, or even a postdoctoral researcher. All you have to do is to be wanting to volunteer your time towards chemistry, do outreach, and be under 35. And so you volunteer your time. In my case, for outreach activities, I was a part of the conference committee. That's the title, the conference committee. And so what we do is just trying to outreach to different parts of the world and parts of different activities that we do. And so one of them was to translate a demo experiment. As you can see here, it was translated to Spanish, but we received it, my colleague and I received it in English, and so we were able to translate it in Spanish, and that was dispersed to the Spanish-speaking IUPAC national committee countries. And so that's a very interesting way for you to volunteer your time if you know a different language to translate a demo experiment. I also got the opportunity to moderate a IYCN Science Cafe with the IUPAC president, Dr. Javier Garcia Martinez. That was extremely interesting. Get to know his experience about his path into IUPAC, his current involvement with the IUPAC, and he was able to tell us the top 10 emerging technologies that IUPAC presented in 2021. And so I was very pleased to be part of this really interesting webinar. But from my transition to IYCN, I was also involved with Division VI, and that's the reason why you're here today. We are a chemistry and environment division, and so because I received a PhD in chemistry, in particular with a specialization in environmental chemistry, I was very much interested in working with Division VI. And so early on in 2021, when I became part of IUPAC and IYCN, I was involved with Division VI from an early start, and I was fortunate enough to be invited to a project. And as Roberto said, you are part of a division through projects. And so in 2021, we presented, my co-chair and I presented a topic to IUPAC, saying that we wanted to investigate the global scenario and challenges of radioactive waste in the marine environment. And so it went through a review process, just like you were to be proposing a draft manuscript to a journal. And so we were lucky enough that my co-chair and I, we got involved other scientists at the Division VI, and we were able to start officially in March of 2022 with this amazing project. And so far we have about 9 scientists from across the world involved in this really interesting environmental project. And like Roberto said, it is the best way to be involved with IUPAC, sharing your knowledge and wanting to publish a paper with IUPAC. Thanks to my involvement with the Division VI project that I'm currently co-chair of, I was able to attend a really interesting meeting. It was a quadruple meeting in Siem Reap, Cambodia. It was my first time in Asia, and I cannot stress it enough how impactful it is to attend these conferences with IUPAC. For me, it was my very first time, and it was my first time getting exposure to these amazing scientists from all over the globe who are much more experienced in presenting, are much more experienced in IUPAC projects. And honestly, it is the best way to be involved as a scientist with IUPAC, and it's a great way to professionally develop yourself. And so the IUPAC the IUPAC part of this quadruple conference was to talk about the current, Roberto mentioned it, a current project in microplastics in the environment. And we were, like I said, it was my first time presenting our work. And here you can see the co-chair to my left with another member of the project. And it has been my pleasure to be working with Dr. Nicholas Priest. He has been an excellent resource for me in this project. And so if you get involved with IUPAC, you're not only working with scientists from all over the world, but you're working with people that have and share your expertise, and they can only help you. And so this was a really great opportunity for me to be part of IUPAC and present our current project. But currently, I am working as a research scientist in the Material Science Division at Lawrence Livermore National Lab. And I just put this slide here because if you don't happen to know this lab, maybe you were able to hear it in the news this past December, in which we became pretty famous, I would say, because we were able to do a nuclear fission experiment that resulted in a net energy gain. And so this is a really breakthrough experiment that can only help the environment if we use clean energy and not so much coal. And so this is me being proud of my involvement with the Department of Energy. And so I invite anybody who would like to work in a national lab in the United States to apply. You have to go through a rigorous process of saying if you can be accepted or not. But if you have, because it's a world platform, I do invite people to contact me if you have questions about working in a national lab, because it's only rewarding. In 2023, now I'm shifting gears to the YO program. And in 2023, because of my involvement with IUPAC and my current job, I was able to apply to the Young Observer program and got accepted. And I'm now part of a 10 Young Observer platform cohort. And because of this, we're able to attend the IUPAC General Assembly and IUPAC World Chemistry Congress happening this August in The Hague in the Netherlands. And this is another reason why IUPAC is only beneficial to us in a professional way. And so I encourage you, if you're part of IYCN, if you're part of IUPAC, to be applying to these programs, which are a 2-year commitment. And again, you're only share your experience and your professional expertise with people like you, chemists like you. And so I'm now concluding my presentation. I just wanted to share some lesson learned that happened with me as a student and now a research scientist and anything in between. It might be funny to mention this, but I do want you to look at your spam folder, because if it wasn't for me being curious to see what was in my spam folder, I wouldn't have been involved with the IYCN and IUPAC. And so that was a huge lesson learned for me. Another lesson learned has been to network and branch out. If you want to volunteer your time on something that is only going to help you grow and be part of something outside your niche, please reach out to the IUPAC Division of Interest. Another lesson learned is to be open to learn. I'm learning so much about different types of chemistries that I was not really involved during my graduate career. And so it's a great word to learn about microplastics, about tires. And so please be willing to learn. Another thing that I've learned during my involvement with IUPAC is to practice your elevator speech. You're meeting people from all over the world. You're meeting scientists that are different. They're chemists with different expertise than you. And so you are wanting to tell them what you do, who you are. So it's important to practice your 30-second, a minute elevator speech telling them who you are. And trust me, it will only help you. And lastly, it goes without saying that you should be respectful and thankful for their willingness to help you and your ability to be spending a platform with such prestige scientists. This concludes my presentation, and thank you for your attention. And if you have questions, we'll have it at the end of the presentation. So thank you all.
Thank you very much, Sylvie, for sharing your experience. It was really useful, and I hope all the young scientists who are attending will find it very useful. I think so. So thank you very much. As I said, we are a little bit late because of technical problems at the very beginning, so we'll leave the question to the end of the webinar. Thank you. And so let's move to our third speaker. And we go from US to Nepal. We welcome Dr. Jyoti Giri. Dr. Giri, she is currently assistant professor at Tribhuvan University. She has involved in research works on biodegradable polymer composites fabricated with natural fibers, polymer degradation, recovery of valuable toxic and rare earth metals extraction from e-waste, and plastic e-waste management in Nepal. She got a PhD in chemistry with a thesis on degradable polymers composite at Tribhuvan University in Nepal. And today she will talk about research advancement in polymer technology with natural fibers and waste management. Thank you, Jyoti, and please, mic is yours. You're probably muted. I can't.
Oh, yeah, fine.
Okay.
No, it's working.
Great. Yeah. Now it's working.
Thank you very much, Elsa, for the nice introduction. Is my slide visible?
Yes, yes, that's fine.
Yeah. As Elsa told that my research is like here. So I would like to welcome all of you in this presentation. So first of all, I go to with my outlines that I'm going to talk in this outline in today here. I come from South Asian country, middle line between the India and China. It's a country of Mount Everest, and I come from the central part of the country. Professionally, I'm associated with different organizations as shown here. And but among them also, I basically come from Trichandra Multiple Campus. This is the affiliated campus of Tribhuvan University. Talking about my connection with the IUPAC, I am connected with the Nepal Polymer Institute, which was established in 2010, and it is a national adhering organization of IUPAC. So it is a non-profit government organization, motivates and explores the polymer research, collaborates with different institutes throughout the globe, and do the research practices, promotes the young generations in our country, and conducts many national and international conferences. And for this also, the organization was awarded for doing the nanotechnology practice in Nepal. And the member of the Nepal Polymer Institute, they are involved mostly in the polymer research. They are mostly guided by the Professor Dr. Rameshwar Adhikari, who is the founder president of Nepal Polymer Institute. So about my journey with the IUPAC, it begins in 2015 by attending one of the general meeting of IUPAC in Busan, Korea. At that time, I was able to present my poster and was able to also attend many division meetings as a young observer. And at this similar context, in 2017, I got a fellowship with the IUPAC as a support to attend the Polycar conference in Malaysia, where I also got the Best Poster Award. Later in 2018 also, I was supported to attend the international conference in green chemistry by IUPAC in Bangkok. Later, in Nepal also, we had conducted the Polycar conference in Kathmandu. At that time, I got the opportunity to serve as program coordinator. Later, I also attended the general meeting of IUPAC in France, Paris. And at that time also, I attended many division meetings of SPED, Polymer Education, Cameron, and CCE as a young observer. The IUPAC provides me many collaboration with many dignitaries and very famous scientists of polymer science. Among them, I would like to mention that very recently we had conducted completed one project with Professor Supawan and Professor Jyoti Zakaria from Malaysia. And the project was the small-scale chemistry workshop for the teachers from government high school. And the program was also supported by Professor Butichai Parasuk from Chemical Society Thailand and Bank of Thailand. The program was in 3 phases, and one was in 2 days in-house workshop in Nepal for 100 government high school teachers, and later the video competition was organized to select the 10 best teachers who were sponsored to participate in IUPAC conference PACON 2023 in Chiang Rai, Thailand, where they were trained as trainees to skill up their networking capacity, and they also able to learn many more small-scale chemistry. These are some of the pictures of the journey. I cannot stop showing this picture that from 2019 we were conducting the Global Women Breakfast in Nepal, and this year we have conducted in 8 different places in our country. And in 2022, our pictures was also in the homepage of IUPAC Global Women Breakfast. So these are some of my connections with the IUPAC. And talking about my research, I'm not doing many research work, but however, I have about 22 publications and 11 general articles, but I had attended more than 42 international conferences. And at the same moment, I have some experiences of conducting the national and international campaigns and conferences. And most of our activities are featured in some of the Facebook of myself and the Facebook of the Nepal Polymer Institute as well. Regarding my research and grants that I have done, I obtained for my research is from the University Grant Commission and focused on the polymer composites and the nanomaterial, the Ayurvedic plasmas. And recently, I'm working in extraction of different precious metal from discarded electronic waste. From this, you might have known that, and Elsa also told about my that I work with a biodegradable polymer composites with natural fiber, basically to reinforce the mechanical strength and to increase the biodegradation in the polymer composites and to study their degradation behavior. And the second phase of my interest is also related with some of the electronic waste and plastic waste. So how I can get connected with the environment. So these are some of my research work, and going to my plastic research, I would like to show this slide where in my research work during my PhD, I have compounded the biodegradable polymer that is polybutylene adipate coterephthalate. It was fabricated with the microcrystalline cellulose and nanocrystalline cellulose extracted from the agricultural waste with stock. And the fibers, the micrograph of the fibers are also shown here. Diffractogram is also shown here. So they were compounded with each other so to prepare the composites, which have the reinforcement of in mechanical strength. Here the stress strain curve shows the increase in mechanical strength in the polymer composite due to the addition of this plant-based microcrystalline cellulose and nanocrystalline cellulose. And here also the micrograph of the fracture surface also indicates the composites on fabricating with this MCC and NCC gets hard and stiff. And for the biodegradation, if the molecules or the materials become hydrophilic, then it is good. So incorporating this MCC and NCC from plant, the hydrophilicity in the polymer composites increases. And this is shown by the contact angle value. And contact angle value for these materials on incorporation of microcrystalline cellulose and their extent of incorporation, that increases. So the materials on fabricating with these materials becomes more degradable. And these degradable polymer materials on soil composting, we see that the composites on soil composting are started to degrade into the soil as the fungal and microbial growth are seen there. And at the same moment, after 6 months of time, the composites were completely vanished from the soil. So the degraded sample were analyzed for the same micrographs and GPC analysis. And at that time, the fibers, they get degraded, and the molecular weight of the polymers, they degraded from 48 kD to 18 kD. So the fibers that are in the composites were what is the phenomena in how they get degraded. To observe that, we had take out the fibers from the polymer composites by dissolving all the polymer into the toluene solvent where the PBAT gets dissolved properly. So fibers, after taking back from the composites again on analysis, we saw the cemented layer on the fiber surface. And the diagrammatic pictures can be shown as this, where on melt mixing, this fiber with the polymer, they form some type of the hydrogen bonding with each other, and so that on composting, fiber being the plant source gets degraded easily, and the connected polymers at the same time also get degraded. So this could be the phenomena behind the polymer composites get degrades on incorporation of these MCC and NCC from the plant source. So these are the parts that we are practicing in polymers. And another parts is the plastic waste and the electronic waste. So these waste materials were also used for some other parts. So talking about the electronic waste, there are different methods to recover back the materials they are in the electronic waste. And pyrometallurgy, hydrometallurgy, and biometallurgy, I prefer the hydrometallurgical process to take out some of the valuable materials from it. And here on acid leaching and using the green solvent like thiourea, we can take out some of the metals from it, very expensive metal, and they can be characterized by the EDX methods. So on doing this, the silver and gold were extracted in our work, and these are this green is the complex where we had precipitate out the silver and gold by using the green solvent thiourea. Later, another experiment was also conducted by the co-precipitation method to take out the metallic copper from the electronic waste. On doing that also, we were able to precipitate out the copper about in 99% purity. So this way, the electronic waste can be used to extract the valuable material. At the same time, the plastic waste, here in this work, our waste cover of the water bottles were collected, and they were compounded with the lantana camera charcoal. They are also occur in our nearby place as a waste. And at the same time, the sawdust from the carpentry were used to fabricate these waste plastic cover bottles, and they were melt mixed with each other to have tiles like shape as shown here in the pictures, which can be used as for the tiles for flooring purpose, and at the same time the fuel as well. These materials can be for use in different application, but still some of the work are pending here to explore its mechanical strength, thermal property, and calorific values, and some more characterization techniques also. So here I just like to conclude some of my works here that we are practicing here. The MCC and NCC from the plant are capable to reinforce the biodegradable polymer like PBAT, which is the copolyester. And during this, the mechanical strength also increases, and the biodegradation phenomena also increases in the polymer composites due to the formation of the hydrogen bonding between the fiber and the copolyester. So this is one first part of the conclusion. And next I would like to conclude is with the hydrometallurgical extraction of very expensive metals like gold, silver, copper from the PCB board, which is very complex, is supposed to be. So it can be done, and waste plastic can be used to prepare the tiles for flooring and briquette purpose. And with this, I can say that the work that we are practicing here is directly connected with the Division VI of the IUPAC, where we talk about the chemistry and the environment. So here are some of my acknowledgements, and with this, I would like to introduce my research group of eWest, who are working in Tribhuvan University Research Center of Applied Science and Technology. So thank you very much for your kind attention, and I'll be happy to answer if there is any question. Thank you, Elsa.
Thank you very much, Jyoti. It was very interesting, your experience, and to hear about your work. So thank you. And thank you again to all of our three speakers. So we have a little bit of time for questions. So I invite all the speakers to open their webcam if they want. Okay. And let's start very quickly. We have a question for Roberto. He mentioned during his talk, but it's better probably to repeat and to highlight that. So how can we get involved with the IUPAC project, and is there a summary available online or a place where people can learn more about ongoing work?
Yeah, I thank you for the question. As I already mentioned, it's very important for us to carry out very relevant projects in our topics. So if IUPAC has a very good and informative website where you can find all information about different things about IUPAC, and also there is dedicated section on projects. So from that web page you can learn which kind of projects can be submitted to IUPAC. There are also instructions on how to submit them. Then each division has some differences in terms of the topics that can be dealt by the projects. Of course, if you are working in environmental chemistry, you should submit a project to the attention on the Division of Chemistry and the Environment. In particular, on our web page, so we have a dedicated web page as division. you can find, as I showed you, the call for proposal. Every year we publish this call of proposal where you can find the subjects of interest for the division. The subject change, I don't want to say year by year, but on a time basis, because as you learn from my presentation, we try to address the most relevant and urgent topics in environmental chemistry. So you can have a look at the web page to have information about which topic can I apply for. Okay, I can develop even my project. Right. And when you submit a project, then you are not alone, in the sense that it's better that you interact with the people inside the division through the participation with the two subcommittees that I showed you, that are also listed on our webpage. So it's better that you, when you submit your project, then you contact the division that can introduce you to other members in order to develop further the project. As Sylvie showed, we are very supportive also of young researchers, young scientists, and we try to develop together with them an international team. That's very important to have international team with also where more experienced scientists can support the work of younger scientists. That's our aim. So I hope I could explain better.
Yeah, thank you very much, Roberto. We can post maybe the website link in the chat, so for all the attendees to join. So we have a very quick question for Sylvie, if you want, is how is working in a national lab different from academia or industry?
That's a great question. I'm sorry, there's a meeting going on here. That's a great question. It's very different. The difference between the most different aspect of academia versus government versus academia, I would say that you are working towards a goal. You're working much more towards the government, so much not focused on publications, and budget becomes a little bit more restrained, right? And so, for example, if you're giving a particular amount of money for your project, it runs out. And not so much, I feel like that's not so much of a problem in academia. In academia, you're very much focused on research. You're focused on research here, but it's very much more applied here because we have a goal, and that is to be serving the government.
Thank you. And so our time is going, but can we have just a quick question for all of you, maybe a quick round. So what has been your favorite memory or experience from your time working with IUPAC? Maybe we can start with Jyoti.
Okay, thank you for the question. For me, a very memorable time I spent is in France when there was a general meeting, and I could able to see how the GA meeting go on and all the procedure. That was quite memorable for me, but that is quite internal. But in practice, I was quite fascinated and very much proud that just last year in 2020 October, we could conduct one accomplish the small-scale chemistry in Nepal, which is very needful for the country, because at the time the Bank of Thailand, Chemical Society of Thailand, even in Nepal, the teachers associations, the Nepal Academy of Science and Technology in Nepal, everybody was so harmonious and worked together to accomplish that program, and that was quite exciting and very much. It will be, let's say, it will be a milestone for the chemistry education in Nepal. in terms of the practical, how teachers do practical experiments with the students in Nepal. So that is quite exciting work that I have experienced with the IUPAC. So thank you.
Great, thank you, Jyoti. Maybe let's go quickly to Silvi or Roberto.
Yeah.
Okay.
Okay. Yeah, I can just tell one of the last experiences that also Silvi reported. So, as president, we could organize a very nice event in Cambodia in November last year, where it was quite important because after 2 years of pandemic. It was the moment where we could rejoin as a team, because I think it's very important to stay together and have some team building activities. So after so long time, we could meet again as a division. So that was very important. And also we met the local university in Cambodia, and that was very interesting and relevant activity where we could present to the local students our activity as division to report how important are certain topics for the environment, for the world. Yeah.
Great, thank you very much. I don't know if Silvi want to add one word.
Can you repeat the question one more time?
What's your favorite memory or experience within IUPAC? You already told in your talk.
I think it's known already. I think everybody knows what it is. Going and attending the IUPAC conference in Siem Reap, Cambodia was my favorite one so far. It's been amazing thus far. So thank you, IUPAC, for that amazing opportunity. Very unique. Thank you.
Great, thank you. So I'm sorry we don't have much time for more questions, but I hope that all attendees or people that are interested in continue the conversation can reach you out through IUPAC contacts. And with that, I don't know if you can see my screen.
Yeah.
Yep. Okay, so let's go to the conclusion of our webinar. First of all, let me thank our speakers. Thank you very much for sharing your experience and your path, your all of your experience within IUPAC. And let me very briefly acknowledge all the members of Division VI that supported the webinar and the Young Observer Group of Division VI. And I named only Michelle Bailey, which has done an amazing work in the organization, and also Laurie Ferriens with her help also during the webinar with taking care of the chat and questions. So thank you very much, Laurie. If you want to jump in for a quick announcement of next webinar.
Yes, thank you so much. Congratulations, everyone. This has been a wonderful webinar and a great way to restart Chem Voices. So our next webinar is coming up on May 31st. The link to register is also in the chat, and you can see it here, the QR code or the link on the page. And this one will be on what is digital IUPAC, tools for an increasingly digital research culture. So thank you very much again, everyone, and have a wonderful day. Congratulations.
Thank you. Thank you, Laurie, and thank you again to all of you for attending. Thank you to the speakers. Thank you very much. See you in the next webinar.